Okay, welcome everyone to our afternoon session for Snowflake training. My name is Randy Pitcher. I am a data engineer with HashMap. We're a data consulting company. And today we're going to go through everything you need to get started from scratch with Snowflake to be comfortable doing some of the most advanced stuff on the platform. We're going to cover a little bit about my company, HashMap. Typically, if you guys come to these other meetups, we don't heavily brand the meetups as being HashMap centric, right? This is kind of the OKC Snowflake meetup space the HashMap employee happens to be a part of. But this session specifically is definitely sponsored by HashMap. The training we're covering today comes from official training at Snowflake Summits and other official events that I think I've probably done 3 or 4 of those for Snowflake. The last one we did in OKC was in March of last year. So we thought it'd be nice. HashMap sponsored some food and of course pays for my time to come out here and do this. This is our office space as well. So you guys are in the HashMap office. So I'm going to tell a little bit about what we do and why our approach is different. Then we're going to get into some setup for today's labs. Hopefully, it sounds like most of you have trial accounts for today. And if you don't have them quite yet, maybe by the time we're done with the pitches and everything, that'll come through. And then we're going to dive into the labs, which I think are, of course, what really makes this training special and hands-on. Anyone can go and jump onto the docs and start learning Snowflake anytime. But if you really want to have a gut understanding, I don't think there's a faster way than these specific labs to really tour the entire capabilities ecosystem. And then we're going to open up to questions. Though this section is probably kind of pointless because I hope you guys will ask questions throughout. And if you ask a question, I'll try to repeat it for the mic so that the recording they can hear. But I want this to feel a lot more like maybe a college lab session, if you ever had any of those, more than like some kind of lecture. Because if this were just follow the rules, hear me talk, you guys could do this at home with docs. So ask questions. Anything that's confusing or interesting, please speak up. Do you have any questions before we get going? Yeah? Okay, cool. Let's go to setup. HashMap. What am I thinking? So HashMap, a lot of people ask me, I go to conferences and stuff with HashMap, and the first thing people want to know is, who's HashMap? What do you do? And we have an official answer to that, but I always like to start in here just with us in the room with my answer. And my answer is that we're data consulting for rebels. HashMap is who you call when good enough is not good enough, when the same old is not cutting it anymore, and you're ready to make moves. We have the experience and we have the ability to develop exciting technology solutions to accelerate your plans, to take you from a 6-month, 8-month timeline to doing that in 4 weeks. That's really what we specialize in. And Snowflake is a trusted partner of ours. We're an integration or a systems integrator for them. And that allows us to have insight into the entirety of the Snowflake platform, as well as some roadmap stuff. So we really make this a core competency for us. Now, the official answer, I think it is still worth sharing, is that we accelerate innovative business outcomes in data, cloud, IoT, and AI/ML with a combination of expertise, best practices, and technology, providing end-to-end solution design, development, and deployment. And this is an accurate description of what we do. This is true. But I often feel like I am forgetting those words as I say them. So they missed the punch. The thing that really makes HashMap special compared to an Accenture or Booz Allen Hamilton, we really stand out because we're able to help accelerate things so drastically, particularly in enterprise environments. Our background's in enterprise. A lot of people, they either see the world as greenfield cloud development, we have to do new stuff all the time no matter what, or it's all enterprise, on-prem, brownfield, old stuff. And we see the realities and the wins in bridging those two approaches to make dramatic analytics changes a feasible thing for an enterprise company without being risky or somehow failing. We have about 180 data and cloud consulting projects over the last 7 quarters. That number is growing. I don't think we've ever had as much expansion as we've had probably in the last 2 quarters. So it's a great time for the company. 150 customers, also that's a growing number. And really interesting to me is how many different industries we play in. So it might not be necessarily like break things down by industry here. The real takeaway is that The problems that we solve or help companies solve, they cut across, they have resonance across industries because data is not an industry-specific problem. We work with massive companies, Fortune 100s, oil and gas has been probably our biggest vertical, though that's shrinking as a percentage of the portfolio because we're expanding so fast. We're in banking, we're in insurance, marketing, retail. We hit all those things. And even within Oklahoma City, we have retail, oil, construction, really all over. So these challenges, these skills that you guys are about to learn, they're applicable really anywhere you go because data is a core problem in the modern enterprise. And we also generate a ton of content. This is another thing that I think makes us stand out. HashMap's fantastic at supporting a developer-led media environment. So the blogs especially, those are worth checking out and subscribing to. The Snowflake content we push out, I think, it really fills a gap where the documentation, which is great, doesn't always give you the real-world gritty experience, doesn't give you the more subjective side of the house on how you should do something, not just what you can do. And then the podcasts, those are a lot of fun. We generate some podcast content regarding IoT, enterprise use cases, and data. So if you're like me, you like podcasts, you like audio stuff, this is really fun to check out as well. Now let's move into setup. So just a final check. 3 out of 4 have trial accounts. Hazel? Nothing. You're still waiting on the Chesapeake or the... Okay, so we'll, if it does come through, let us know and we'll take a quick break to catch you up. The nature of the lab is that at whatever point we get at, you could probably jump in pretty quickly. So everyone else, you should be logged in right now and let's get some content. So this is a bit.ly link. Hopefully you're familiar with this. Open a new tab and we'll just type bit.ly/0 to Snowflake 2019. And that's separated with dashes. This is content from last year, but it stays pretty evergreen. The core fundamentals of the platform, I think, pretty static, though that may change in the future. So this content is just as relevant as it was last year. And this should take you to a GitHub page, my GitHub, actually. So we all have this link. I'm gonna go a little off-road here. Let's open that up. So it'll look like this. This is SQL. You'll notice on line 5 here that this is another link. So if you would open that, copy and paste in your browser window. This is the PDF. This is an S3 bucket that Snowflake hosts, public access for this content. Today what we'll do is just I don't want to say a variation. We are going to do the in-person back and forth talking version of this. I don't like to live inside this PDF for these sessions. I think that diminishes what's really valuable about what we're going to do. But afterwards, if you're like me, you might want to, on your own time, revisit this at your own pace. There's a ton of great content in here, links to other supporting documents, and you can see how every little piece works together, and you can run the whole thing end to end. So I always like to make that disclaimer because I'm not going to necessarily follow this word for word. And then the code. So if we can all log into Snowflake, and I'll show you logging into mine. You guys should see when you log in, most of you logged in, login page, but you'll notice on mine I have a single sign-on. This is part of the enterprise offerings that Snowflake provides. You can have that single sign-on experience that your company probably expects you to use right now, whether it's Active Directory or Okta, or I use G Suite, we're a Google company at HashMap, so I'll log in with that. And hopefully that is maybe not big enough to read, but big enough to know what's going on. And then you can read on your side. I still haven't found the perfect projection zoom in for this kind of session. We're going to dive into a UI tour shortly, but first I want to make sure everyone's logged in. You see a page like this, worksheets, and you have like a space where you could type. Is that true? Yeah? Okay, so before we go any further, let's jump back to the GitHub, right here. And you'll see there's this little button, raw, on the page. Go ahead and click that. And what this is going to do is just give you the raw text, the SQL that's in the file, so that you can do Control A and Control C. We're going to copy all of this. And this is the code for today's lab. That's what's really nice about it, is that the code is so self-describing that it is on its own a lab. So we copy that, jump back here. Now, I already have it in here in a named worksheet, but I'll just overwrite it real quick and paste. And that's it. That's all the coding we're going to do today. You guys should feel empowered to chug along ahead. If you feel like you're getting it, you just want to move forward, write some new code. But of course, you can stick with us at our pace. But don't feel like if you're not super confident with SQL or you're not the strongest coder that today's going to be tough, because we've done all the coding we have to do. And let's scroll back to the top. Okay, so I think now's probably a good time to jump into the UI. Do we have questions so far? No? Okay. So let's focus on this worksheet area. Then we're going to move into these different tabs. And then we'll bring ourselves right back around in a circle to the worksheet to run the lab. The way Snowflake works, what I want to first bring your attention to is this top right area. You should see your name or some indicator of who you are, as well as a role in smaller text. I think for most of you that'll say sysadmin right now. So that's the default when you create an account. Snowflake is going to give you 4 roles out of the box. Roles, they're like groups, right? They describe a level of access that any person can have if they have access to that group or membership. Sysadmin is kind of a typical admin role, but it specifically focuses on objects in Snowflake. The database, the warehouse, the physical things in Snowflake. Security admin is similar, but it's for users and roles, for your security stuff. Sysadmin's special power is that it can create things from nothing. It doesn't have to inherit any permission or own the parent of. It can create it from nothing. And the security admin special power is it can create users and roles from nothing, and it can also grant permission onto objects it does not own. That's a special thing at Snowflake. So you can switch to security admin, wire up all your permissions, and then switch back to your normal roles to avoid making mistakes. The other 2 roles, one is public, and that is just the default role when you create a user. Ideally, this should have nearly no access because everyone has it, and you don't want to accidentally give someone too much privilege. And then there's the account admin. The account admin often gets confused with the sysadmin because at first you're like, well, what's the difference between the system and the account? So the account admin has all the powers of the sysadmin and the security admin, but it also has some account level tweaking it can do, including just destroying your entire account, setting budgets for the entire account. It can see everything. It is such a powerful role that I would recommend that you never use it. Don't ever use it for anything. Now, of course, that is bad advice. It exists, right? There are things you have to do. But I think the advice is simpler by saying don't ever use it. And then when you do have to, you'll know. But normal rules of operation, don't use that. Another thing is that the account admin role should not just be owned by a single person, because if something bad happens to you and you're the only account admin, it can take a couple business days for Snowflake to jump in and help. So whether you get lost or you can't respond, so it's always good to have at least 2, but don't have too many because this is a very powerful role. Okay, those are the default ones. We're going to dive more into what a user and what a role is, so that makes more sense. But these are the default ones. You're going to see them in every account you ever log into on Snowflake. They're good to know about. Now, the reason I'm pointing up here, your logged in context is a description of who you are and what role you are. That informs what you actually see. So some of you may not see an account tab right here as sysadmin. I have a special role. This is my own custom one called RTE that has access to this account level. If you want to see it, go ahead and click up here, switch role, and go to the account admin. We're going to go ahead and break my rule I just said, but today's a lab. It's useful to do it here. And you'll notice the whole page reloaded because it's a rather large shift to switch your logged in context. And it should be, because 90% of the time you're going to want to stay in your lower privilege day-to-day work roles. and only jump up to those high-level roles when you have to do something serious, and you don't want to end up there on accident. Because if you're like me, I've deleted stuff because I accidentally had too many permissions, and you don't want to get in that scenario. So that allows you to see here. We'll switch back at some point, but this is fine. Now, to confuse you maybe a little more, you'll notice that we also have roles down here. These are your worksheets, these individual tabs. And it is the nature of Snowflake work that while running code, you will switch roles. And if you had to reload the page every time to switch a role, even if you have to jump to check to something, then jump back, that would be very painful. It would be, no one would ever switch roles. You'd just stay in the top level. So when you're logged in, everything you do through the UI, clicking buttons, not running code, that is going to be executed as that role context. But everything you run code in is going to be based on your worksheet context. This also includes a couple other things. This is going to have your role, your current warehouse, and we'll talk about what that means, your database, and your schema. So this is fully defining the space you're working in this current worksheet. If I jump to another worksheet, I'll have a totally different role, warehouse, database, and schema. So we can keep different contexts across different worksheets. But the number one thing I find when people are new to Snowflake, when things aren't working right, is that they are not in the context they think they are. They think they're one, they're actually using another. So throughout, you're gonna see syntax like this use. I like to be very explicit at each chunk of code about what role I wanna use. So when you're debugging, you can totally rule out that you're in the wrong role. You can either, just like we did up here, you can either come in here, change role, pick which one you want, and I have quite a few. You guys hopefully only have 4 at this point. Or you can run this code. And this gets to the heart of one of the great things about Snowflake. Most of what you can do, I'd say almost all, of the things you can do with Snowflake through this UI, you can also do with SQL. That makes it incredibly powerful for automation. For someone like me, if I'm debugging with someone or I want to send a fix, I don't have to send screenshots with click this, then click that, or try to organize a video share. I just send a SQL file. Hey, this will fix your problem. Don't worry about it. Or run this, tell me what it came back with, and I know now the debug results, I can fix things. So whether you're doing internal troubleshooting, if you're doing automation, all of that, having the ability to express rather complex UI interactions as SQL is one of the best parts of Snowflake. Not all the warehouses can say that. So at parts here in this PDF that we're working through, they're encouraging you to use the UI. I've gone ahead and written the SQL that would execute the same thing here. And I'm going to encourage you guys to continue doing this. It'll keep you from having to debug kind of simple things in the long term. Any questions about that? Okay, so on the left here, we have kind of an explorer that maybe makes sense for what databases you have available. You guys probably have some default ones. Let me go down here, because I notice I have not deleted things from before. And I'll go ahead and run that. This is just a cleanup. The lab also doesn't have this, but at the end, you guys may decide, you know what, I want to get rid of everything we've done today and act as if it's a fresh instance. I have clean code here to do that, where if it was just UI driven, I would have to tell you the steps to undo these 5 or 6 things. Okay. So here's your Explorer. You really are just looking at tables, databases, and schemas here. So if I just click on one, single click, not double click, and I go in here, I can see all my different tables where they exist. I can click on one, I get a little information about it. We're going to come back with real stuff. You guys obviously don't have this, but I just want you to be comfortable with what's here. It's nothing more than just almost like a file explorer for your database. Now over here, this is where we're actually going to write SQL, and a lot of your work will live here. Your exploratory work for sure will come in here when you're just exploring things, running code. You'll get your results down here at the bottom, along with a little information about how those results were reached. And then you have a little history that you can look at. We'll get to this hands-on. You guys don't have to memorize this or anything. But this is the main interface for interacting with Snowflake. They have other options, right? So you can get an online command line tool or download a command line tool that lets you run SQL files. or do interactive querying from the command line if you prefer that. They have Python SDKs. Snowflake, one of the great things is that it is compliant with lots of different standards. So ODBC, JDBC, if you have an existing tool set that lets you work effectively on database development, you might be able to use that with Snowflake today, just because they've implemented these standards. And then, of course, your BI tools are going to treat Snowflake as a first-class citizen in almost all cases, because it is such a dominant market leader. Another good advantage for using it. So this is the worksheet. We're going to live through most of the lab here, but let's tour the UI a little bit. Any questions about the worksheet? Cool. Let's jump into the databases. So I always like to start here because it's probably the most intuitive part of Snowflake. Databases are not necessarily like you might think in on-premise worlds of like their own kingdoms that everything resides within, and they don't really talk much to other databases. A database is just a top-level folder for your data. Think about it as a folder on your desktop. It is the top level, there's no other parent to go into, and you just use it for sorting things out. Whether you put things all in one folder or you use multiple, that's up to you. That won't really impact your underlying performance. It won't impact how you work with things. If you have it all in one folder, it's harder to grant individual permissions, right? If it's all in one folder. So that's kind of the way to think of a database. It's just a named folder for holding everything. We can go into one of these. We'll go into the one I had earlier. Or we could probably go into one of your guys's. So if you're the account admin right now, you should see Snowflake as a database. This one's interesting because it is a shared database from Snowflake. They are sharing your usage statistics back into your account for you to consume and look at. Okay, well, they're all views, excuse me. Okay, so this is where tables would live. I think the next logical place when you click on a database to go to is the schema. So schema, in lots of different databases, schema can mean different things. Here, it's just the next level of folder, nothing more. So your top level folders on your desktop, that's your database. The next level within there, those are the schemas within a database. And then that's it. You have no other levels of folders, no other levels of differentiation. Your patterns you use to design schemas in databases, they're no different than how you decide to set up an archive structure in your Windows or in your File Explorer. It's all up to you. Just use what makes sense for your business. And in here, you can see we have organization usage and as well as account usage. Account usage is really useful for if I want to see line item billing for everything that's happened here, I can get that information as a table from account usage. I can even build a dashboard on that. That's one of the powerful features of Snowflake. So what kind of things exist in the bottom level folder? What does this contain? Well, left to right, we have tables, which I think probably makes a lot of sense. These are just where the data is actually contained. They're logical names pointing to the data. Snowflake is going to store your data differently depending on what cloud you're on. So if this is an AWS Snowflake. So the data is physically stored in S3, which is an AWS technology. It uses the equivalent technology for both GCP and Azure on their side, but it's similar conceptually, if that makes sense. Views, that's a SQL thing. They're just like views you may already know about. They are a collection of SQL that actually points to other physical stores. So when you hit a view, you're not actually getting physical data. You are actually running a subquery defined by the view that hits real data. It could define a join. It could define data flattening, complex logic. Those are really useful if you need to get data in a different format instantly. But they can have some performance impacts, right? They're not always going to be as fast as a table. Next are stages, and we're going to talk about this. This is more of a Snowflake-specific thing. But you can imagine, okay, views and tables, that's a database thing. I get that. I've seen that before. Databases and schemas, they're just folders to hold those things. But how do I get data into Snowflake? How do I take data that exists somewhere else and pump it in? A stage is how you would do that. So remember, Snowflake's storing this data on something like S3. They're storing it there. If you have your own S3 bucket with CSV files, TSV, XML, Parquet, ORC, lots of different formats, Snowflake supports all of those. You can create a stage. I can even click create here. That contains all the information that Snowflake needs to access that data. It includes a pointer to where it's at. So a URL, let me try it. Oh, you know what? I don't have permission in Snowflake database. Let me go to one I own. Oops. There we go. I already have some stages here. But I can collect different for each of the clouds. And it doesn't matter which one I'm on, it's supported across all of them. So I'll click on S3, and it'll tell me what things it needs. I'll give it a name so that other people can leverage this information without having to type in the URL, the credentials, the file path, all this other kind of onerous stuff. They can just use the nice name called My Stage. I'll do some credentials in here, maybe some encryption, and then I'll do a comment. And one of the great parts is that anytime you're doing some of these create statements, you can jump and see the SQL that would do the same thing right in the UI. So this is a great way to get familiar with doing kind of complex stuff and starting to automate things you're doing by hand. We're going to make some stages later today. They're kind of like riding a bike, right? It's hard to explain in the abstract how someone rides a bike. It makes sense though once you try. So this is how we're going to point to locations where data is stored outside of Snowflake. They also have internal stages, but I think it's more useful to think of these in the context of an external data source. So, okay, so say we have one of these stages and they store CSV data, but we have a weird format where we use pipes instead of commas to separate that. That's not unheard of. How would I tell Snowflake about that? Well, I could configure it every time I load, like, oh, by the way, these have pipes. There's 2 rows of headers. We have a really weird format. Please skip the first 2. Also, if there's any errors, just go ahead and move on. I can configure all that in the right code at time that I'm ingesting, or I can create something called a file format, which is just a named collection of these rules. So if I look at one I already have, I have CloudTrail logs. So across all these different file formats, you can have different levels of compression. So I can tell it what to do here. Well, this is just an edit, but if I create, I can say what schema to hold this in, because again, that's just a folder. The file format here is CSV, but maybe I want, instead of a comma, I want to do something else. I can do other, I have a pipe. So the configuration here for how to set up the rules to ingest and properly understand the data, you can set up, and they have some pretty advanced stuff as well, including like date formats, timestamp formats, how to handle errors, whether you actually break or whether you just continue, or even if there's a threshold where continue unless you get more than 5% error, then you should break. So these are all in here, and then you can see the SQL to do that. Oh, I gotta give it a name. Right here. Not super well formatted, but this is everything you would need. And after this, instead of having to remember these complex rules, anytime someone wants to ingest data that they know is of this format, they can just reference the name of the format, and Snowflake will remember all these rules. Yeah? Sequences, not super worth getting into right now. This is a database thing though. This is for when you have rather advanced SQL that needs a number that gets bigger every time you call it. So going from 1 to 1,000,000. You could either have a table that gets big like that, or you can have this object that every time you call for it, it gives you the next number. That's useful for some computation, but not super valuable right now. And then you have some other things that exist here, but you don't see here. They don't really have a UI way to make. And that'd be something like a user-defined function or a stored procedure, something called a pipe, which isn't something we'll talk about today, but that helps you have cheaper data ingestion. We have quite a few number of lower level objects that don't have a UI component, but they all still exist within the schema. Does that make sense, how we're going to store things physically in the Snowflake platform? Any questions at all? Okay, well good, because this is what I would consider, it's rather intuitive, right? Like, I don't think anything I'm saying here like is breaking anyone's brains. Like we have folders to store things in, and here are the things we store there. Totally simple, not that different from what you guys already do. Now let's get into some more interesting stuff. I'm gonna skip these next two because they should come later. Let's go to warehouses. Can we all click there? So Snowflake, it is not Snowflake's fault. Naming things is hard. That's a hard thing to do. But I think in this instance, they probably picked not a great name. And it's one of the biggest sources of confusion for new people. Snowflake is a data warehouse. And then these are what warehouses? Are these individual Snowflake? It's confusing. So the way to think of these are called virtual warehouses. And they're not like a warehouse that you might think for on-prem, where, well, we put the data in the warehouse, and the warehouse holds the data, and we query the warehouse for data, and the warehouse runs our query. It's not like that. These are just units of compute, just clusters. They're dumb. They don't know about data. They have no data in them. You can't query a warehouse. But if we just have those storage objects, the databases, we have a table. If we want to find out the average value of a certain column, we need a computer to load the data, compute that, and give the answer to me. So the piece in between, my data's here, but it's not yet aggregated the way I want, or it's not computed right, and I want an answer, that's where a warehouse sits. So every time you run a query that needs to do computation, you'll need to give your SQL the right engine to compute with. And that's what a virtual warehouse is. Now these things, they're ephemeral, right? They turn on, they turn off, they get bigger and they get smaller, and they're totally isolated. So if you overload one of your warehouses, you don't have to worry about that impacting your production warehouse. And this is a slightly different way of thinking. If maybe you've worked on a production environment where maybe a data scientist runs a rather complex query and it brings everything down. Your production stuff stops, you've lost data. That can be a pain. Or say you have dev test prod, you're only ever in a limited subsection of power in those smaller environments. You really tightly couple your capability, your ceiling of effort or of compute with the environment you've purchased. And here with Snowflake, you no longer have to do that. So we can look at some examples of warehouses I have. You probably have compute warehouse right now. I have something a little more lengthy in name. I have the Sigma Cloud Cost Monitoring Reporting Warehouse. The name is so long because warehouses don't exist within schemas. They do not have folders. They just are all top level at the same level. So you have to have a naming convention that allows you to separate them and mix and match. Your charges from Snowflake are usually aggregated at the warehouse level, not the person level. So by having lots of individual warehouses, it's easy for me to see if a warehouse is really high. I know who's using it and why the cost is being driven. Whereas if I just had my compute warehouse and it was really high 1 month, I don't know anything. Who did that? Why was it high? Is that normal? Should I do something? So here I have a convention where I have the actual entity using it, which is Sigma, which is it's like Tableau. It's an online visualization tool that I use. Cloud cost monitoring is the project. So that way I can have multiple Sigma dashboards that don't interfere with each other. I can have one that has really high compute and it needs to be on all the time. It's rather expensive and performant. And then another one that's more of a toy. It hits this general small warehouse and it's okay if it's a little slow. And then I have reporting warehouse at the end. This allows me to aggregate costs across all my reporting tools, BI, Power BI, Tableau, Excel, anything like that. So it's not something you guys have to worry about right now, but you should get into the mindset of using these names to indicate some aggregatable level of billing, because it's going to be the easiest way. That'll make more sense when we look at the billing information later. Again, warehouses make a lot more sense when we use them. So if you don't really have questions now, you might later jump in. I mean, any questions so far about warehouses? Yeah, no, it's hard because it's a lot. So these will make a lot more sense. The big thing to remember is that they're ephemeral. They turn on and they turn off. They can scale up momentarily, then scale right back down. So always treat them with a sense of caution. So if you have like the small warehouse, that's a name I've seen before. It's a bad name because the small warehouse could actually be a 4XL and be charging you insane amounts of credits, just be burning through them. So make sure your naming has more to do with what you're doing with it than with the configuration you think it has. Okay, now we can go back to shares and data exchange. Shares are really interesting, and it's really where I think the future is. Snowflake has solved, I think, the challenge of warehousing data and clustering compute and not having to constantly be administering that manually. They've hit that sweet spot, and that's cool. That's enough to build a business on. But I don't know that it's an empire builder the way that data shares are. I like to tell people data shares is like being really good at computers in the 70s in Silicon Valley. Like this is the future. And you're going to see some huge increases here that change the way we think about and work with data at an enterprise level. Often you'll hear people say, oh, we want to free the data. Really what they mean is they want to put the data for a company in one spot. And that's free to them. Shares allow you, without copying data, without sending snapshots, to give live data access to your internal data at a fine-grained level, right? You don't give it to everyone or everything. It's very secure. But to a specific table or a specific level of row access to an external entity that uses Snowflake with no copy, and it's always up to date. So imagine that your business relies on sharing data with people. So people subscribe to your data that you would typically send as really large zipped files through Excel. Like you sell housing data. You do surveying, you have inside high quality housing data that goes to some real estate brokerage, large firm, and they subscribe from you. Well, it probably costs you a lot of money to send all that data out and to prep it, and to, if there's an error, like fix everyone's copies that you sent out, like, oh, okay, here's the updated one. And then they have to manually open it, load it into some other place. Hopefully there's no errors. And at best, you maybe get a copy every day. With this, there are no copies of the data. It is the single source, and everyone, if there's a fix, you just fix it. And they're getting live access to this, but they don't charge, they don't have to pay for that extra storage. They're just accessing your existing storage. You don't have to duplicate anything. You can revoke it at any time. And all their compute, which is really the usual driver in Snowflake of cost, is the compute charges. That happens on their account. So right now, we've done a couple shares with like partners, or if you guys have shared ventures with an external partner, this is a really great way that's auditable to make sure that live data, clean data gets to everyone, but nothing that shouldn't be there crosses. But it's not on its own, I think, what's going to show the future. And I didn't realize this before. Do you guys have a data exchange tab in the top? Yeah, so this might be a beta feature Snowflake's enabled for us, and that's pretty common in my environment. I'll assume everyone has it, but it's actually kind of a new beta feature. And this is the data exchange. The data exchange is a way to market that from before. So say you're a data engineering company like my own, and we have some really clean data sets for specific environments we've worked in, oil and gas. That's a key vertical for HashMap. And maybe we have specific clean metadata that maps weird metrics from oil and gas field values, because they use all different kinds of metrics that aren't necessarily like IS standard or SI standard metrics. Maybe we have a good mapping from that to conversion ratios to like a more standardized. So we can get your miles, your feet, your inches, all that into meters. We can do that with everything. Instead of everyone having their own copy of that, we can maintain that and post it here and then charge subscriptions for people to use it. And I don't know if the subscription charging part is here yet. I think that's probably a future ad. But if I just want to promote my company, that's an easy thing for me to do. It doesn't cost me anything. I have that data anyway. I can share it in here. So this is like, early days app store, iPhone app store. It's something to keep an eye on because I think it's going to change how we think about data engineering. Does that make sense? This is kind of a taste of the future right here. Okay. But that's empowered. The underlying technology is the share. Okay, and then we already did warehouses. Let's jump into history real quick. This is one of my favorite tabs. I don't think we've ran really any queries unless it's reporting what you've done in the UI, so you might not see anything. But you'll see an exhaustive history of all SQL ran on my instance. And it automatically will filter depending on your role and access level. So you don't have to worry about, everyone all the time has access to every query. But as the account admin, I know everything anyone's ever run up here. dbt Cloud, this is interesting. This is actually a service account. So it's not just your humans that are running queries. I can see the exact queries that happen from service accounts like Power BI or Tableau. And that makes it very easy to debug. And when I have a specific kind of query, let me see here. Let me look at something that took a little bit of time. 5 seconds, what happened here? You can click on this query ID, and each query has a global or a universally unique ID. This makes it really easy to copy this URL and share with a coworker to link directly to the profile of the query. This is the SQL that was run, And I can see the output. Okay, so output as a security feature is only made available to the role that ran it, or the user that ran it. And if I go to the profile, I see a breakdown of every piece of the processing pipeline here. Now this is a view creation, so there aren't like individual steps, you just create the view. But say I'm querying a view that has 2 or 3 joins, I can see what parts of that actually are bottlenecking the process, and I can direct my optimizations to fix the bottlenecks rather than just going in circles on something that won't actually move the needle. It's also really great for just debugging in general. We'll play with this a little more hands-on, but this is a good thing to know about, and I think probably underutilized early on. These kind of metrics would be incredibly difficult to get or generate yourself on other systems, and Snowflake makes it incredibly easy to do. Okay, and let's go to the account tab. Hopefully we're all account admin right now, and this one's kind of fun. What do we got here? Okay. So first of all, we're going to look at billing and usage. So Snowflake charges you in 2 major ways. The first one is your data storage. I think this makes sense to a lot of people, right? I think it's like $23 a terabyte, depending on your tier, and that's per month. And I mean, a lot of the clients I work with, they don't even have 10 terabytes of total data in their whole organization. Uncompressed, and now these are compressed charges. So 10 terabytes, you're talking about $230 a month at the enterprise level. That's really nothing. The time it would take you to consider fixing that is going to cost way more than the $10 or $13 you could save, right? So that's important to know. I'm not saying don't optimize. I'm just saying if you're going to optimize anywhere, make sure your compute is well optimized, because that's where the dollars are being driven by. And then, yeah, go back and look at the table. But your speed that you gain from maybe being a little wasteful, storing data multiple times, and in different redundant ways, if that allows you to reduce your compute, always take that trade-off, always. Okay, and then next is the compute, and that's what we see this nice chart here. These are my different warehouses. And you'll see that the default out-of-the-box visualizations that you get showing your usage is at the warehouse level. So if I have a poorly described warehouse name and I see that, oh my gosh, it's like a huge spike, I don't know what to do about that. I've got more work ahead. But when I've got a good name like the Snow Alert Cloud Trail Flattening Task Warehouse, this tells me a couple of things. This is a task I have running. It's a scheduled task for a Snow Alert Cloud Trail source. So Snow Alert is my monitoring that I do across different cloud platforms. Cloud Trail is a source from AWS. That's all of our logs, everything that happens there. And flattening just takes the Cloud Trail that comes in as JSON and turns it into structured data in a database that a BI tool could leverage. So that's another great part about Snowflake, is that it can easily handle your semi-structured data through XML or JSON. So that's why I encourage you early on, especially, to start naming your warehouses descriptively, because you won't have to build a custom monitoring solution. You can just go straight to here. And then I can see by day what's actually happening. I see some pretty big spikes here, and I see RTE warehouse. So RTE, that's my official job title at HashMap. So this is really just me or my cohorts. I think there's 1 or 2 other just like me driving this. If I want to dive in, I can see hourly how it was being charged. And it looks like it's charging 1 credit per hour. And this is really useful. So credits in Snowflake are how you're charged for compute. They cost different amounts depending on how much bulk you buy, but the sticker price is $3 for the enterprise level. If you're like in maybe banking or healthcare, you might be paying $4 per credit for the much higher security offering, but typically we're talking about $3 a credit. Credits, and this is the most complex we'll get, 1 credit is the charge for running 1 extra small warehouse for 1 hour. An extra small warehouse has just 1 computer behind it, just 1 node. If you bump that up and you get 2 nodes, that's the small warehouse. Every level up doubles. That is going to burn 2 credits an hour. So it's a linear scaling of charges. The next level up, going from 2 to 4, is medium. How many credits does that burn an hour? 4. Yep, great. So the math is pretty simple. As far as granularity, like it doesn't like you turn it on and it just runs for an hour. Snowflake charges you by the second. So the second is 1/3600th of a credit. I hope I got that math right. But there's a minimum every time you turn it on. you're gonna get charged for 60 seconds as soon as you turn it on. Every second after that, you get charged per the second until you turn it off. So when I see here in my usage chart that I'm burning 1 credit an hour, and I know that this warehouse is an extra small, what does that tell me about my usage? Any thoughts are fine. Okay, was this ever off at any point in this period? Wasn't. So I know whatever I'm doing to burn through this is keeping it on all the time. That's a really good indicator. I've either set my auto suspension too high, meaning it's keeping itself on because I configured it wrong, I didn't tell it to turn off, or whatever I have using it is pinging it faster than every second to keep it on. So that's a really good intro to how you might debug this kind of stuff. Luckily this isn't, I knew what I was doing here. And it was an experiment, and I learned quite a lot from it. But this is kind of your billing and usage. Storage, I can come over here. This is just almost never worth looking at. 28 gigabytes? Man, I don't know. That's, even if it was a terabyte, $23 a month, that's less than $1 a day. It's not even worth looking at. I bet I'm spending more time talking about it right now. More money of HashMap's money talking about this than I could ever hope to save unless I just deleted everything. So that's a good thing to know. Data transfer. This is not very common, but this is a part of the cloud that if you export data out of Snowflake, Snowflake doesn't charge you. They don't care. You do whatever you want. The underlying cloud Snowflake uses, they do charge you though. And they have different rates. As long as you keep it within the same cloud, within the same region, you don't have to worry about those charges. So if you're doing some more advanced machine learning use cases, you'll save a ton of money by making sure your Databricks instance is in the same cloud and region as your Snowflake instance. Things like that are pretty simple. So that's how you can get a grasp on your charges. Though data transfers are usually not a big concern, neither is storage. Most of what you're gonna be looking at is the credits. So I've burned 114. That's just north of $300 in human dollar terms so far this month, so not bad. We actually implemented some dashboarding on this data because a great part about Snowflake, all this data you're looking at is presented to you as a table in that Snowflake database I talked about earlier. So I connected it to Sigma to drive cost monitoring. And I have a report that fires off to our Snowflake Slack channel. It's just an image of the report scheduled every Friday at 3 that shows usage. And just by doing that, I was able to cut our costs by more than 80% on compute. Just by showing people what the costs were, because people were gonna start self-regulating. They'd leave things on, but if they see a spike, everyone thinks, oh no, I hope that's not me. And I didn't have to do anything as an admin. So that was really nice, and that would have been really difficult to do in a different system. Okay, still continuing through the UI. We have our users here, which you should just see yourself. I could create a user if I wanted to, and this is where I can configure single sign-on, I can configure different password policies, and of course I could show the SQL. If I'm not super comfortable creating users by SQL, I could do it here, or I could start here, copy the SQL, and then I have a template for automation in the future. Now users in Snowflake, you can't actually grant object permissions to them. Like you can't give read access to a user. Users are just the entities that represent a thing connecting. So me as a person, every person should have one. Your service accounts, those are really the two big ones. Any sort of like running long-term processes that connect in. So these represent what is connecting, that's authentication. But now our authorization, our permissions once you are authenticated, those are roles. So we had the 4 we talked about, but you can create any kind you want. And in Snowflake, you grant read access to a role, and then you grant that role to a user. And then you can have hierarchies as well. So you can have read access to role A, warehouse access to role B. Those both go to role C as children, and then that C goes to a human. Now this human has access both to use a warehouse and to read out of a database. This can get sticky rather quickly, and that's part of the service offering HashMap has, because if you go too granular, it is a ton of work to keep up to date, and you will mess it up, and it's gonna be a lot of work to identify where it went bad. And if you guys are using Snowflake today, maybe you've been there. And on the other side, people probably just stopped bothering with good security controls, and now everyone's an admin. We just over-provision, grant them access to everything, whatever. They'll quit bugging me. That's especially prevalent in teams where the admins and the devs are different, they're separate. You see that dynamic quite a bit. So striking the right balance, it's definitely something you can do where you're staying secure while still staying maintainable, but that takes a little bit of experience. Policies, this is a network policy, really, for allowing or blocking IPs. Don't go home and allow your home IP address here, whitelist it, because your home IP is almost certainly not static, and if it changes, you're locked out. Your blocked IPs, however, you can add those. A fun one to add is just all the list of Tor endpoints, for like dark web browser, that traffic from Tor would be coming out of. You can block all of those, unless you expect some people at your company would be using that to connect. If you wanted to implement network policy here, you could add a range of IP addresses that maybe correspond with your internal VPN, and then people can only connect if they're logged into the VPN. So this is a pretty simple way to get started with network policy, but make sure you don't lock yourself out, because I've had people do that as well. Sessions, this is just a breakdown, not just of who I am, but how many logins I have active. So if my credentials are compromised, I can come in here and look at a specific session and try to identify if it's valid or not. Like if Randy Pitcher is ever logged in with a password, I know that's an invalid session because I only ever use single sign-on. But that's some more advanced kind of admin stuff. Resource monitors, these are great. Let's make one of these. Let's do a little something. They're just budgets. They're targeted towards the warehouse credit users level. So we can go create one right now. You have to be account admin. This is one of those special things account admins can do. And let's give it a name. Let's call it our monthly budget. So I care about all of you, and I don't want you to burn through your credits on accident, particularly if it's something I did. You ran something today and you didn't turn it off. Credit quota. You get 200 free credits right when you fire up. So I don't know, do whatever you think is appropriate. 50 maybe, or 100. You don't want to burn past half of your spend without actively looking. I'll do 100. And then you have different levels. So for one of my Sigma dashboards, that's publicly accessible. I have a public URL I share with clients all the time. And you can conceive that maybe a bad actor, or even someone on accident, would just ping that dashboard over and over and over and over, and just kill my budget, have it running 24/7, right? And that'd be, even on extra small, that's a credit an hour, 24 hours in a day, times 3, we're talking like $75 a day. And what if it takes me a week? I mean, I could be at $500 in spend before I notice. So I can click the warehouse level and then select my specific warehouse, or here, demo warehouse, right? And then I can give it a 100 credit limit, 50 credit. My specific one for my public dashboard is 20 credits. I don't want to spend more than $60 a month. I almost never do. I never do. It's more like 5 or 10. But this allows you to go to that level. Today, let's make an account level one though. So this will, over all accounts, doesn't matter who drove it. Let's create a budget. I'm getting a little orange there because I already have one of these. They want you to use just one, but you won't have this. So you can set your budget and guarantee that it won't go beyond this. And then we have some rules. So I can add as many notifications as I want. At a certain percentage, in my real one, I do 20, 40, 60, notify me every time. But then at a certain point, I need to suspend. I need to stop taking new work. So say at 95%, I want you to stop taking new work, but still finish up, right? But if you hit 100%, then you tell Snowflake, kill all active jobs, kill everything, shut it all down, no more spend. And you can do that over different time limits, right? So I have monthly here as my time period, here customized, but you can also do daily or weekly. I think monthly is pretty common in our industry, but use what works for you. But go ahead, I would say definitely do a monthly one here, set it at 100, maybe notify yourself at 100% of that. You don't actually need those individual parts. And then you can click create. You can also see the SQL here that would create this as well. But there's no problem with just running create. So I encourage you to do that so you don't run out of spend. I especially encourage you to do it if and when you apply payment information to Snowflake. Because if you don't, it could just keep running up the bill, right? So this is a good practice. And it's an easy one to do day one, right? Any questions so far? Okay. So now, reader accounts, these are interesting. We're not going to dive into them too much, but you remember the shares we talked about? Data sharing only works if the other party has a Snowflake account, but it's kind of new. A lot of people don't. So what if you still want to share this data live to someone that they can interact with, they can do dashboarding, but you don't want them to have an account on your Snowflake instance? Reader accounts are great. They have their own different URLs. You can see these are totally different spaces. They don't know anything about your space. They couldn't begin trying to hack into your space if they wanted to. And you give someone else the management of that. You will still pay for the compute here because it's on your billing account, and they'll have a subset. They couldn't see the account level tab and look at your stuff. But your partners could then begin to leverage Snowflake. And this is a really great in-between option when you still want the value of the share with people who don't quite yet have Snowflake set up. That's pretty valuable. But beyond the scope of what we're going to talk about today. The last little tabs up here, we have Partner Connect. That's really fun. So Snowflake's a SaaS offering, right? And there are other SaaS offerings within this ecosystem. Snowflake's focused on the warehousing, but what about getting data into Snowflake or automating that process? Something like Fivetran or Stitch, they're fantastic at that. And they work seamlessly with Snowflake. And then what about visualization? Sigma, that's the thing I use the most, but you can also use Periscope. You can use any number of these. So because this are all cloud-based solutions, I can click Fivetran here, and it would generate within my warehouse all the things I need to properly wire up a new Fivetran account to my Snowflake, and it'll take me to Fivetran and create a new account for me with this email, and I'm up and running with a free trial ready to go, one click. It's an incredible use case. I encourage you to experiment with these, with maybe your personal emails, and it's a real cheap way to find out whether this is worthwhile doing in your enterprise environments. Fivetran especially, you can't beat that. And then Sigma, the dashboarding, if you guys are using any other sort of visualization tools right now that aren't cloud first, beware with Sigma because you will not want to go back. It is such a breath of fresh air. Rather than having to fight with installations and configure things and licensing, forget that, just use Sigma. Okay. Help, this is a great, normally help we ignore because it never actually helps, but this is good information. The documentation is here, that's worth having. The documentation is really well written. They have community boards as well for asking and answering questions. I just use Google, no need to go straight to the community. And then downloads, these are worth looking at. There's the CLI I talked about. They also have ODBC drivers. You'll need to install this if you're using Power BI, for example. And then Python components. I do a lot of Python coding, so I can get the connectors here. I can write custom logic. I can do serverless functions that take action on behalf of things that change in Snowflake. So it's a really rich ecosystem. And I think with that, notifications, that's your personal preferences on how and when you'll get notifications, and then our context. But I think we're ready to go back to the worksheets. Any questions so far? No? Okay, cool. Hopefully this didn't bore you too much, but I think we're ready to run a little code. What do you guys think? Yeah? Cool. So let's get started. First thing, module 3, right? So I've documented this, so if you did want to tie the specific SQL back to that PDF, you can do that. We're not going to look at it too closely right now. The code's pretty self-explanatory. And I think the first thing we should do is get some data into Snowflake, right? All this cool stuff is fun, but it's useless if you can't get any data in. So the first thing we're going to do is set our context. Let's use a role. And yeah, we might already be using that, but let's run it anyway. How do you run a command? So if you click in here, anywhere in this line, and click run, it'll run the command. If you highlight a line and click run, it'll run the highlight. Actually, when I got started with Snowflake, that's all I did was the highlight. However, if you forget to highlight all of it and you just run this, you get an error. That's invalid SQL because all it saw was role sysadmin. So it's only going to run what you highlight. This is valuable if you have a nested query and you just want to see the results of that sub-nested query first before the whole thing. Just highlight the middle part. Run that, and you can run the whole thing. And of course, if you want to run 2 lines, highlight them both, click run. What I often like to do, though, is if you have a cursor in a specific place, nothing highlighted, if you're on a Mac, do Command Enter, It totally runs. And if you're on Windows, it's Control-Enter. That's really the way I think, once you get used to it, you'll start running things. And it's how I run it today. So we do use rule sysadmin. This command, you can run as many times as you want. You won't get an error. But other commands, of course, they're not idempotent, meaning you can't run them twice and things will be fine. So create database, right? Let's create this database. We're the sysadmin. That's the role that lets you create things from nothing. So we're using good security practices. And you guys should run along, too, on your account. Okay, so it successfully created it. Now, if I go over here to my Explorer, I'll look for City Bike. You don't see it. Where's City Bike? This is a good lesson to have. This little thing does not update itself near enough. So this little, up top, there's a refresh button. Get comfortable pushing that. A lot of errors I have are people like, oh, where is it? I made it. It's not there. Click the refresh button. It's there. Always double check. So I can click City Bike and we'll see, we just created the database, but it already has two schemas. One is public, which has nothing. That's a default schema. And then information schema. This has quite a bit. This is where all the metadata about this database is stored, and you can query here. One of my favorites is the load history. So for all data loads that happen within this database, it'll track what went well, what went wrong, lots of metadata about all the loads, and I can build an alerting dashboard off of this and say, show me all the failed loads, and then break that down by what caused the failure. Again, really difficult to implement that in another tool, and this just gives it to you for free. So we'll close that back up. Now, what happens if we run create database again? We get an error, it already exists. So many commands in Snowflake have the ability to qualify it, like if not exists. It ran just fine, but it didn't do anything. Or I could do create or replace, which can be dangerous. Now create or replace, if it doesn't exist, it'll create it, no problem. Replace, if it does exist, it will wholesale delete it and then recreate it. So if you had stuff in there, that's gone now. Be careful with these. An error is not the worst thing in the world. I actually think right here, create database, you want an error if it already exists, because you probably don't think it does, and that's a surprise, right? So let's not fail quietly. Don't be afraid to throw an error now and again. Okay, so now we're running SQL. We have a schema and we have a database already set up. Move this back. So let's go ahead and set those contexts explicitly. You may look and see that it already has you set there, but it is always a good idea to double check. And let's create a table, right? That's what we're here for. So this syntax, create or replace, again, this is going to destroy it if it exists. And we're going to call the city bike public trips. This is called a fully qualified name, and not everyone uses it. If you use city bike and you use public as the schema, you can just go ahead and call this trips if you wanted. Some people like that. I'm paranoid, and I've been burned too many times. I like to have the full name in there. I don't want there to be any ambiguity about what I'm doing, especially when I'm creating or deleting things. It's one thing if you're doing reads or exploring. It's another thing when you're doing full admin stuff. And the syntax should feel pretty intuitive. We're calling these different column names, and we have different types. Nicely formatted so you can see the difference between the column name and the type. And that's it. We're not putting any data in at all. Let's run this. It should be successful. Trips created. Now, who's familiar with City Bike here? That's okay. You guys know the Lime scooters, though? So City Bike's a really similar idea, but for just bikes. You have a subscription at a city. I think I went to Purdue, and I think they had City Bikes there. You just come up to one, you do the scan, and they start charging you. You ride it around, and when you're done, you scan it, and you're done being charged. Luckily, Snowflake has some City Bike data, some real-world data from New York, I think, that has lots of different information. You can see all these different columns, in particular start time, stop time, and different latitude and longitudes for where it started and ended. And you can see how this information might be interesting to making business decisions at the City Bike company. So that's the table we're going to create, and we're going to ingest some data. So stage, thankfully, you guys took my word when I said we'd get to it, and hopefully this will make it feel more comfortable. I'm creating or replacing a stage called City Bike Trips, again within that database and schema in that folder level. And I'm telling it the URL to where the data is. And that's an S3 URL. Normally, I would have to provide some more information, like some credentials to access. Luckily, Snowflake themselves, they host this data, and it's public. You can access this any kind of how. So the only information that the stage needs to be able to get that data is just the directions to it. The name makes it easy for people who, maybe they're SQL friendly, but they're not necessarily code friendly. That stuff might be a little complex. They don't know exactly how to put it in. You put it in once, or say they change the location. If you don't use a name stage and you just reference all the connection details every time you use it, and you guys change the location that you put in the data, if you have 5 data flows, you now have 5 places to fix. Where if they're referencing this name, I can just update the stage and all of it will be fixed in once. So that's kind of the value of being able to reuse this stuff and use these more friendly names. It's not just about clean code. Okay, so we should run that, and that'd be fine. And now let's actually test it. List is a special command that's just gonna list all the files. A stage is expected to hold files. That's how data is ingested first class through stages into Snowflake. The @ symbol is just identifying that that's the city bike stage. And this is a great way to see if your connection works, especially when you're using authentication, because you're not actually ingesting any data. You don't have to do anything destructive or permanent. Just list, just what's up there. And you should be able to run that and see there are 376 rows. These rows have quite a bit of information about the file. So the name, this is the full path to the file. There's multiple ones there. We have the size, the MD5, that's a hash function. It's just a unique fingerprint of the content of the file today. So the MD5 with the name gives you a unique understanding of the data without having to read all the data. And Snowflake will use that when you copy data in. So say I copy all this data, and then a new file gets added. Do I have to totally refresh everything? Or somehow tell it which one to add? No, you don't. Snowflake will only add in data that doesn't have the same matching name and MD5 hash. So you can run copy multiple times, and if there's nothing to copy, nothing new, you don't worry about it. But if there is new, they'll pick it up. So that's very convenient. Again, you can override all that functionality. And like the modified date. So we are making an established connection to an external data source. This is the exact kind of behavior you would do in a production environment. This is just not a toy lab. Only difference being that you would have probably some authentication. And let's create a file format. So Snowflake is able to identify where the data is, but we already talked before about CSV can mean a lot of things. My CSV is different from your CSV. In this case, it's no different. I know for a fact that there are some weird things about the CSV data we're looking at. So we're going to create a file format. It also exists in the public schema. We're calling it CSV, the idea being that this is the only CSV data we'll get. This is just the CSV we'll use. We're using a type of CSV, which is going to preload some standards that Snowflake already has, and then we're going to overwrite some fields. So field optionally enclosed by, think of this like as a quote, right? So imagine a CSV of Amazon reviews. And you have the person, the star rating, the product, and at the end you have the actual written text. Well, if this is a CSV, I mean, people use commas, right? So you could escape each one, or you could just wrap the whole thing in double quotes. That's a standard. And all you're telling here, and this is what happens in the source data, is telling Snowflake that this source data, it has one of those quote mechanisms to look for that. Otherwise you get weird column shifts. I'm also telling it a little data cleaning. The data coming in from the JSON has certain fields, null, underscore, or lowercase null, and then just an empty string that can cause issues down the road. And we just say, you know what, if you see any of these, go ahead and replace it with a formal null in SQL. And then we tell it how to handle errors. So a specific kind of error is that a specific row might not have enough columns. And that might be a parsing error, maybe not. And we're telling it, don't throw an error on that, be resilient. And there are a ton more of these options. But you don't have to set them all, right? You can keep it as simple as just CSV. Oftentimes that works just fine. So that's why we're going to create one. Let's create one of those right now. Creates just fine. And that is the end of that module. But we didn't load data, so let's just keep going. Any questions so far? Cool, all right, great crowd. Let's create a warehouse. So as we've talked so far, we've identified where data is. We told Snowflake how to read it when it gets it. We made a place for it to put it. But we don't have any engine to move, read, and store that data. We don't have that power. So we need to create a warehouse. So let's create this compute warehouse, which you guys probably already have, so it won't do anything. I didn't have it, so it created it just fine for me. And now, just like we're always going to do, let's set our context. We want to be the sysadmin. We want to use this new warehouse we just created. We're working in the City Bike database in the public schema. That's a good pattern to get into. And now let's actually copy data. So the structure of this copy command, you could be pointing to really anything you want. Another table, a generic function that just has some output. But for me, we're going to do the trips table into it from the trips stage using this named file format that we just created. And because it's a demo, I'm going to go ahead and say, if you see an error, just continue. Don't have a fit about it. And I believe this doesn't actually have any errors, but this helps you to understand how you could do that. And there's even some really interesting, like, okay, per file, if error rate is below 5%, ignore the errors. But if it's above, then go ahead and throw an error. So there's quite a lot of flexibility. And this should take a little bit of time. This is 60 plus million records. I think it's over a gig uncompressed. And I don't know what the compression looks like on the S3 side. So it should take a little bit of time. Great. Mine took about 30 seconds. That sticks with what happened earlier. That we did have someone, it took over 2 minutes for them. Couldn't explain that, no idea. Sometimes things just happen. And I can see some information about it. This data is what will happen. It'll be stored in the information schema load history. So this is the exact kind of information you can come back to later over time. Or if you automate this, you can dashboard on it. I can see really easily how many errors we're seeing in a file. And it looks like 0 across the board. So that's good. And these are all the different files, 376. That matches the number of files we listed earlier. We're good to go. Now, if we go into City Bike, we'll go ahead and refresh. Again, that's a good habit to get into. Go to public. We have our trips table. That exists. If I click on it, I get some quick facts about this. Some of this metadata, it's a great thing about Snowflake, they store it. So you don't need a warehouse to identify how many rows are here, what's the size, to describe it. Those are metadata operations. So we got more than 60 million, we got 1.6 gigs, and we can see the different columns and their types. So, I'm a fan of writing the SQL explicitly, but one UI, nice to have function I really do like is if you right click on trips, hit preview data. This just does a select star limit 100, I believe. It might be 1,000. It's 100, limit 100. And you can see the data. We have, especially those latitude and longitudes, those look really good. Names of the stations, right, throughout New York, and those start times. So this is a really good way once you've loaded data, just double check. Does it look okay at first glance? You don't know perfectly, but you can check. And that's the kind of data we have. So it took about 30 seconds to load, right? I don't know what you guys had. Was it faster for you guys? How long did it take? About 30 seconds? Okay. Well, let's go ahead and up the size of the warehouse. And what we're going to show here is that for different activities, even with the same warehouse, if I know I'm going to do a load operations distribute really well, usually per file. So if your files aren't massive, you have like 100 meg files, 1,000 of them, well, go ahead and fire up a big instance because Snowflake charges linearly. So if you have double the compute, it costs double the money, but it'll run in half the time. I know, it's kind of a tongue twister, meaning it'll cost you the same amount of money, but it'll be done twice as fast. So not everything works that way. Some things just won't scale. Like if you throw double compute, it won't take half time. It might take 20% less time. So then you have to make that judgment call, is it worth it? So what we'll do here is truncate the table. Truncate is just going to erase everything in there. It's a really nice, easy term. The table still exists though. Treat it like it's empty. And then we're going to alter our warehouse, the compute warehouse. We're going to set it to large. It was small before. So let's think about how much bigger that is. We do extra small, small, medium, large. So that's 1, 2, 4, 8. We're going from 2 to 8 resources, right? So it should take a quarter of the time if it scales linearly, perfectly linear distribution. And let's run the same copy command. Took 30 seconds before. I believe it'll take 10, 15 seconds. It's not a perfect 1/4. And a lot of that has to do with I/O. There's just certain things you have to do to wait, no matter how big your warehouses are. Okay, 18 seconds. So to my eye, this one costs 4 times as much, but it was only a third gain, 30% gain. Not worth it, especially at these scales. But this is how you can start thinking about warehouses as more than just these static obelisk objects that are in the server room that you treat them right because they could break everything. No. They're like ephemeral. They're cattle, right? They're not your pet. They're not your loved family member that you hope never dies. They're cattle that come and they go, and you want to be nice to them, sure, because they're living, breathing things. But you're not personally attached to any individual piece of them. That's pets, not cattle. That's not my analogy. That's a DevOps thing, but cool. Okay, so we have data. Now let's create a new warehouse. The idea here being we have this compute warehouse that's really driving all of our loads and our transformations. That's our workhorse, right? But this isn't necessarily going to want to play nicely with a analytics style workload. Reason is, for ingestions like this, your latency, meaning from when I ask for something to when I get it, it's okay if that's kind of long as my throughput, how much data I process per second, is really high. So we're going to optimize that to not necessarily be on all the time, to maybe have a cold start that adds 5 seconds to execution. That's fine. That's totally fine because it's automated. We don't worry about it. It just needs to be reliable and be cheap per data that we put in. Whereas our analytics is going to be a lot more sensitive to latency because there's people involved. When they open it, they want it right now. They don't want it later. And they don't know exactly what they're looking for usually in analytics. So being able to iterate very quickly and get responses fast, that adds to the bottom line in a way that, would it really matter if we cut our latency in half on our ingestions? Probably not. But here, it could matter a lot. So we're going to create a new warehouse for a different analytics pattern. And that's the end of the module. Any questions? Cool. Okay. So what do you think we're going to do first thing in this new module? Anyone? You know. I know you know. I won't pick on you. We're going to set our context. We're going to get used to that. This is not something that Snowflake forces you to do. I would encourage you to do it. It's just good wax on, wax off, build the muscle memory. This is good stuff. We'll run all that. And now remember, we did our select star limit 10. You can also just write SQL. We're going to limit 20 here. Take a peek at this data. It's fine data. I don't necessarily see any insights jumping out. It just looks like data. If I'm a BI person, I want to put this in Tableau right now, play around a little bit because it looks interesting. But it doesn't do anything for me. So, of course, the next thing, once you have data in Snowflake, you want to be able to play with it. You want to clean it up, do something valuable with it. So let's run a serious query, something non-trivial. And I'll walk you through it. So we are going to do a select statement, truncating the start time as our date. And it's really going to go to the hour. So we're creating hour buckets, right? Date maybe is not the best term for this. We might call it date _ hour or just hour or something like that. And then we're getting the number of trips within that bucket. And we're calling it number of trips. So now we're aggregating by the hour. And then we're getting the average of trip duration divided by 60 as the duration in minutes of the trip. So that might be a metric you care about, like per hour, what's the average trip duration? Are people taking longer trips at night or during the day? Those are good business questions. We divide by 60 because the data is natively in seconds, right? So just divide by 60, take the average. And then this one is really interesting. It shows some of Snowflake's more advanced functionality. Haversine is a complex function. The people who were in here earlier, they actually had implemented Haversine by hand. They knew how complex it was. Have you too? It was Chesapeake who did it, right? So now, wow, so that's really cool, right? So everyone's doing the Haversine function. Out of the box, you just give latitude, longitude on each side, and then we're going to do the average. So first Haversine is going to compute for every row, and then within this bucket, you take the average of that. And what we're getting is a distance that I guess accounts for the curvature of the earth, is what I'd heard. But it's as the crow flies, right? So no one's actually going to be plowing bikes through buildings to go straight to where they're going. So it's an approximation, but it might be useful as a metric. You guys have seen those, the bird lime, or the lime scooters, and they have those trucks that go around and pick them up. Maybe you've seen that. If people are scattering the stuff everywhere, your budget for truck expenditure has to go up. Because on average, this location, people just like to scatter it all over. So this might be a good metric for the bike people as well. So we're gonna grab all that from our trips data. We're gonna group by the date, so that's grouping by the hour, and then we're gonna order by the hour so that we have chronological data. Let's go ahead and run that on our analytics warehouse. And now I'm starting to see a pattern, right? So we're starting on August 1st of 2013 at midnight, and 152 trips happened during that hour, which is insane to me. That many people wanted a bike or started riding a bike at midnight, cool. And then it goes down as we hit the early morning hours. I don't know what time zone this is in. I suspect it's UTC, but it could just be wall clock time. It might be that, so we're assuming it's Eastern time. And then where do things pick up? Okay, you get a spike around 8, 9 a.m., 10 a.m. Okay, you're really getting there around noon. You know what? I bet this is in UTC. I bet this is a 5-hour offset, or 4, depending on daylight savings time. So it really spikes up. I'm just scrolling here, and then it goes back down at night. Cyclical. It's exactly what we'd expect, but we're starting to get some insights here. Trip duration, I don't know that there's a lot I can tell just by looking at this as a human. But this is how you would begin to do that. This, of course, would be gorgeous in a chart. But the time it took, let's look, 2 seconds and 2.44 seconds to run this. Not nothing, but it's a good bit of compute. It wasn't sub-second. So let's run it again. Let's run this query again. My warehouse is about to turn off. It's been a little bit. So I'll run it 2.44 second time to beat. And I got it back in less than, what are we gonna do here? A fifth of a second, right? 151 milliseconds, so fast. And my warehouse is off, by the way. This is one of the most powerful features of Snowflake is the result set cache. If you run a word for word identical query in Snowflake and the underlying data has not changed, it's able to check that without actually checking all the data. You will get the results back instantly from the cache, or pseudo instantly, right? You don't have to recompute, and you won't be charged for any warehouse time. It just goes straight to there. Another cool part is, say we're all on the same cluster right now, or the same Snowflake instance. I run it, it takes me 2 seconds to get it. The rest of you running it, you also hit the cache. Doesn't matter if it's me, as long as you have read access on the underlying data. So this cache hacking is a thing HashMap does a ton to help people save money and speed up their BI queries. This is the kind of thing you can really take advantage of to drop costs and improve performance. So it's a lot of fun. You'll see a lot of this kind of thing. As far as like the limit of what you can cache, from when a query's run, it has a 24-hour clock before it'll get purged. If data changes, of course, that's automatic purge. They'll never ship you stale data. But if someone uses that result within that 24 hours, it resets the clock to another 24. And you can keep chaining the resets over and over for 30 days. After which, you got to recompute it one more time, you get another 30 days. Usually your data will refresh in there anyway, but there are companies that they get a ton of free performance out of Snowflake by knowing how to leverage this really well. So it's a cool thing to learn about. And you can always check. So if I go into query ID right here, let me click on that. This is a URL. You guys can do this too. It gives me that breakdown, right? Ooh, what do we got here? This doesn't look right. This looks like a error. Let me refresh the page. Yeah, there we go. And I can see the exact SQL that was ran. This is really interesting as well if you're using something like Tableau. You don't actually know the SQL that it's running, right? You're just pushing buttons. So if you had something weirdly slow and you want to see, or you have a data quality issue, you can click in here, see what your Tableau user ran, and you can look at the SQL raw and see if there's a mistake. So this is a great way to debug. But I can see my results too, as long as I'm the person who ran the query. So another person, even an admin, could not see this result for me. And the profile. The profile will tell me how much of this execution was in different stages. And again, it's just the query result reuse. You can tell right away, no warehouse used, nearly instant. If we go back to worksheets, you can just click on worksheets. And I open history. Let me look at this 2.44 second one, the one I just ran. This one did not hit the cache. What does that look like? Here we have the full description of the different steps and what percentage of time they took as a part of the whole. And I can see the table scan took the most time, just looking at the data. Aggregation took the next amount of time. That's going to be our group buys, right? And then we're going to sort. That's the last little chunk. So if you're trying to decide, like, oh, this is an expensive query, do I really need to have it sorted? That it would be more efficient not to sort it. It's probably not worth it. Even if you don't sort it, what are you going to save? 2% efficiency? That doesn't matter. And then on the right side, across everything, I can see the two big numbers I care about a lot, the processing percentage and the remote disk I/O. So if my processing percentage is really low, I don't gain anything by having a bigger warehouse necessarily. Sometimes you do. I definitely don't gain anything by optimizing my query, like using a better function or something, right? Because all of it is an I/O. That's going to happen anyway. So if I see high I/O, I know I need to store data differently. Maybe I need to redundantly store data that's already processed. Say, right when data gets loaded, I decide to calculate the haver scene right away. And all I do here is the group by. That might be something that's useful because the aggregates are really what's driving some of the costs. And we can combine these two into one. And then the other way around. If I'm trying to wonder, like, is my view really slowing me down a ton? Do I need to persist that as a table? Well, if you come in here and see the processing is the major bottleneck, well, okay, in that scenario, yeah, maybe sometimes you have to do the table. But if all of your processing happens after the view in the query you wrote against the view, then you know that's not worth your time to make a table. So this is all about optimizing where you put your effort. Really difficult to get this information outside of Snowflake. By which I mean on a different platform. You can get this information pumped anywhere you want outside of Snowflake because it's just a table in your account usage. So a really popular monitoring dashboard would be show me all queries that took longer than certain amount of time or was above certain threshold of percentage in each of those regions. You look for hotspots. And then if there are specific people who constantly have hotspots, they're probably driving your costs. You can go and help them. Maybe give them additional training or identify what they're trying to do, and you can help them not spend so much time doing it by hand. Okay. Yeah, let's move on here. Oh, did I scroll back up to the very top? That's weird. I reloaded the page, yeah. So where were we? Right here. We ran it, we got the cache. Now let's ask an actual business question of this, because these aren't business questions. One thing you might want to know is which weekdays are the most popular for bike rides? Any guesses? When do you think people are most likely to use a bike? Friday and Saturday, right? Weekends when I would use a bike the most. Friday and Saturday. Let's find out. So we're going to do a count star across different weekdays. This is a function again in Snowflake, and it's in descending order. So this top value is the most popular day, and it's Wednesday. Fridays and Saturdays, they're in the bottom half. I thought the same thing you did. I thought Fridays and Saturdays, perfect day. But I don't know what's going on here. Maybe people just, they use it mostly for commuting, and on the weekends they do other things, okay. And then maybe Mondays, too early in the week, right? Let's call an Uber. I'm not biking. But that Wednesday, you see the weekend coming, right? Thursday, I don't know, the hump of the week, that seems to be more popular. But this is interesting. If I'm a city bike, and I also thought naively, like, yeah, Saturdays, Fridays, that's when our biggest demand is. And I start making business plans on that without seeing something like this, I might do something harmful. So this is, again, more of an ad for why analytics are useful, but particularly showing how fast you can go from question to insight with Snowflake. On a data set, like, we're not city bike experts here, and we're already able to contribute to the strategy of a company we don't know anything about. And now let's create a table. This is really interesting. So in lots of other environments, say you want to try something new on production data. You can either just do it because you're reckless and risk breaking things, Or you can make a copy of production, and maybe production is super large, so you just grab a subset of it, and you start messing with it in your sandbox space. In Snowflake, you don't have to make the distinction. You can take a production table like trips and create a trips dev by cloning it. This is a special thing in Snowflake. Let me run that. It's gonna be instant. So a couple value points here. A clone is pointing at a specific point in time in the lifetime of the table. Snowflake takes changes to tables and adds them to this ledger, as opposed to actually modifying things in place. So you can always look back at how things used to be at a certain point in time. So if you have this chain of changes and you point to this point in time with a clone, you can start stacking changes in a different branch, a different location. It's fully editable. You're essentially branching your tables just like you would with code. And it's an incredible feature. It's similar to what powers their time travel, meaning if I have data today in a table and it looks weird and I knew it was good yesterday, I can query with an at syntax at a specific timestamp. And I can compare today's data against yesterday's data as if they're two different tables. And that may be very difficult to implement in a different system. And you're not storing any additional data. This comes with what you have. It's called time travel. Cloning is just another kind of cool thing you can do with that feature set. By default, you get a day of time travel time, but you can configure this to go back 90 days. And for audit especially, or really complex workloads where the changes overnight, where it's not just append only, but you have updates and you want to identify which things were updated within certain SQL parameters, this is a must-have feature. And once you've used it, you're going to have the hardest time going back to other systems that don't have this and trying to implement it yourself. And now you can treat it like a full production environment. You can break it, you can slap things together, see what happens. And if it doesn't work, just scrap it. You didn't really spend any money to make it anyway. Okay, so that is the end of our trips module. We're gonna get back to this bike data, but do you have any questions so far? Great. Let's get into some weather data. Everyone, if you're in analytics, someone has asked you before, like, yeah, let's get some weather data in there. Well, I don't think that'll impact things. Yeah, but let's get it in because, machine learning. Okay, fine, let's get weather data. But here, I think that actually is a lot more relevant because we're talking about an outdoor activity probably impacted by weather, right? So let's get that. Let's create a new database called weather. And really what we're showing here, we are showing that the databases are just folders. And you can still work across multiple databases to create products or do exploration. You don't have to think of these as like tough barriers the way they would be in other systems. And then let's set our context. We're going to use the system admin role, compute warehouse. We're going back to our data engineering, not so much analytics warehouse. We're going to use this weather database, and then we're going to use the default public schema that we already created. Now let's create a table. Now this one's interesting. It's a lot shorter. Weather data, fully qualified name, and we're using v variant. Column name is v. And we're thinking of that as value or variant. And variant is the data type. Variant is the data type in Snowflake that lets you store semi-structured data, like what you might find in a JSON. And if it's stored as a variant, different from a string, right? String's just a string. But a variant allows you to access subfields within this JSON. And you can create more database-friendly views or full-on tables to power dashboarding, or really anything you're trying to do. Native SQL just doesn't play nice with JSON. Tableau is not going to take your JSON and do very much with it. So being able to have all that transformation power within Snowflake, where you're already doing your transformations anyway, and where your compute can scale up infinitely and scale back down at the drop of a hat, will become an invaluable part of your data processing workflows. And you can start considering, especially SaaS sources, subscription sources that you have, APIs, things that you wouldn't normally think of as being database ready. They're just another column. You can inject them. So we create this table, and let's create another stage. At this point, this should feel pretty comfortable. You guys have seen stages before. You know what I'm doing. This is going to point to the weather NYC. So this is going to be weather data out of NYC. Snowflake, again, has this data made accessible through S3 without authentication. And let's go ahead and list. That's a good practice to get into to double check everything's working. And we've got 61 rows. Okay, 61 files. That doesn't mean necessarily it's less data, because files can be a lot larger, right? But we know we're connected. and then copy into. Again, this should feel really, really familiar. Now you'll notice we didn't have a named file format. And the reason is this data is not unique. It follows Snowflake's expectation of what this JSON data will do. So we can just use the defaults here. I would still recommend in a production environment that you still name it in case that assumption about it being in conformance with what Snowflake expects, in case that ever changes. Because if you have, again, 5 of these using the default JSON and that changes in the future, you're gonna have 5 places to go look. It'll be a big pain. Okay, so we loaded, that was rather fast, 6 seconds. And they all loaded. Error limit is 1. So because I didn't tell it to be more tolerant of errors, this thing was, any error was gonna trigger a failure. And I see no errors. Great, that loaded just fine. And now if we go over here, we look for weather, you notice it's not there. What do? Refresh. Always refresh. Always be refreshing in VR. Let's go into weather, public, and click on this table, just one click. Yeah, so we got just shy of 60,000 rows and 1.3 megs compressed. So it's about 1,000th of our other data set. So a lot smaller. And it has just the one column. So what does this look like? We could do the right click preview data, or we already have the SQL written here for us. And we have just the one column called V. Click on that, like it's kind of like a link, and it gives you something much more human readable. And we can see all the weather data fields that are in this semi-structured format. Not every one of these fields is gonna exist in every record, because different weather reporting agencies have different standards. But in this environment, we can see the city has latitude and longitude, and the New York, right, has an ID, and you can see across different regional dialects how it's spelled. It's a ton of data just dedicated to that. And then we have specific fields, clouds. The main kind of section here has humidity and pressure, sea level, lots of just different low-level kind of readings. A specific timestamp for when this time was taken, and then a description of the weather. That's really nice. It's overcast and cloudy, and then wind. So this is some pretty useful information. If I'm working for City Bike and I'm trying to decide, well, maybe we should get covered bikes with toppers. One assumption might be that you have a huge cutoff when it starts raining, and that the cost of implementing these covered bikes is going to be less than the increased revenue for additional rides. So let's do a little exploration. Is this something that the company should consider? But of course, there's very little value we can extract just from the JSON. So what we're going to do is create a view. This is going to be instant. It's just a view creation that stores this logic, and we're going to extract these values from the underlying data. V, of course, is the column that we have. The syntax is V:, and then your quoted field. So time, that's a top level one. We're gonna call that a timestamp, and we give it a name. We do that all the way through here, getting different weather information as well from our weather data. And we're filtering for this ID, and this is that New York ID. Because the city bike data is in New York, we really don't care what Seattle weather was like at this time. And that's very fast, because again, it's not running the queries, it's just storing these rules as a view so that when you do query it, it'll know what to do to get the data back. Now let's check out the data. Let's look just for January of 2018. Limit 20, we'll just grab 20 rows. And this looks a lot more like what you might expect from a structured database. The fields have column names, they're flattened more. This is the kind of thing you could plug into a dashboard. New York, of interest when you look at weather, these are like English descriptions. We have snow, clear, clouds. So that's interesting that we have a full description here. So let's identify something. What conditions correspond to high usage and which ones correspond to low usage? So we grab the weather as conditions, and we get the number of records as trips from the join between our trips table and our weather data based on the hour of it happening. Remember our hour start time and then now our hour observation time. So we link people starting because we care more about when they start than when they end. But maybe if we're doing like length optimization, we care more about when they end, what things trigger them to stop a ride. So this gives us our raw kind of underlying table, and the conditions cannot be null because when you're working with semi-structured data, if that conditions field wasn't there, then it would return null. So we got to filter those out, and we want to group by the kind of weather and order by the number of trips descending. So our top thing should be the kind of weather you get that corresponds to the most number of trips. You guys just guess what kind of weather is best for bike riding? Sunny? Yeah, kind of clear. Exactly. I would think the same thing. Let's find out. What weather do you guys think would be worse? Like the worst one? Hail. Hail would be really bad, right? Thunderstorms, bad weather. Okay. Clear. My man has it. Top one by quite a lot. Then clouds, then rain, snow kind of going down. And the bottom one is smoke. Smoke is the worst time to ride a bike. What's wrong with that? What's wrong with that conclusion? Any thoughts? How often do you think it's smoky as a weather condition? Half the time? Maybe less? Maybe like almost never? Probably pretty rare, right? So are we really getting the insight that smoke hurts bike riding, or smoke is a rare thing and people riding bikes during that time is going to be smaller because it just doesn't happen that much? So we get the beginnings of insight here, but there's some additional data cleaning that'll have to happen to normalize for how often it's happening. Maybe you start looking at the end times and you say, what is the rate of, like the percentage of trips that are ended during a specific kind of weather? And if it's 40% when it's clear out, 40% when it's rainy, okay, people don't care that much. But then it's 80% when it's smoky? Well, yeah, because the world's burning. Smoky sounds apocalyptic. Yeah, okay, so maybe we don't need a cover, we need like aspirators so people can breathe in the smoke. Of course, this is all joking, but these are the kind of questions and answer the process that it's really hard if you're working in a more difficult warehouse environment where you kind of have to be an expert, for one. SQL's not enough. You have to know exactly what you're going to do all the time before you can get the go-ahead to go and do it, because you have to go buy some more instances, or you have to worry about impacting production. And this kind of back and forth, this is like a conversation, right? We don't know what we're going to find, but we might stumble across something really, really valuable. And Snowflake allows you to build a warehouse that's optimized for agility and speeding up your innovation cycles. And that's something you have to have in an analytics workflow. That might not be necessary in a transactional workflow, like in banking. Maybe it's good to go a little slower and be a little more sure. But for Snowflake, for analytics workflows, this is the name of the game. And they're optimizing to help you do this kind of work better. Any questions so far on that? Okay. So we can move into Module 7 here, start updating data. But these are the basics that you need. You've seen how to load data in, how to transform it, how to work with structured and semi-structured data. And you've started to experience what it's like to ask questions iteratively within Snowflake, and how quick you can go from raw data landed to interesting insights without even any BI tools. We haven't even begun to discuss that. So moving into Module 7, let's go ahead and drop our weather data table. Okay, and then let's select star from the weather data. Let's see what kind of weather we have. Oh my goodness, it's gone. Dang, I feel so stupid. I feel so dumb right now. What am I gonna do? We're filming this right now. Oh, wait, let's undrop it. Thank goodness. Whew, buddy. Okay, go back, let's select star. Okay, there it is, there's the data. Thank goodness, that was almost a disaster. I could have gotten fired. Undrop is one of the best functions around. This, again, is taking advantage of that same core idea of the data kind of being stacked in Snowflake. And when you drop something, you're not necessarily removing and purging all the data. You're just removing that pointer that connects the table to the data. Just get rid of it. And it has some cleanup that'll happen if it doesn't get access, but within the time travel period, that removal is really just an addition to the chain. At the top, hey, we moved everything, it's empty now. And if you try to query it, it's gone. But if you want it all back, just undrop. It's just gonna pop off that last one. It's gonna go back to the previous state. That's a great feature. It's built in. You could implement this on your own with some more time travel stuff, but this is a pre-built. And now let's set our context. Compute warehouse, we're going back to City Bike. And let's add some manual data entry. Nothing wrong with that. No one's ever been hurt by that. And we're gonna set our start station name to oops. And we updated 61 million rows, not bad. Now let's aggregate the number of trips we have by station. What's our most popular station in the area? Okay, we've got 61 million rides happened at station oops. Oh, darn it, dang again. I've screwed up, I've made a fool of myself. Oops, that was not something I should have done, because now all that data's gone. Let's do a little time travel. So first thing, you can do timestamps, but to get at a point in time, let's set a variable. Query ID is equal to selecting the query ID from the table of this information schema where the query text is equal to update, order by start time. So really, we're looking at the query history by session, limiting by 5, because we know there's not a ton, from this information schema. This is that really powerful thing within City Bike that tracks everything that happens. And the query text is all the SQL that ran. And we're saying, grab me something that is like update, that starts with the word update. And we only did one of those. We're gonna order by start time, limit by 1. So we're really just grabbing the latest update, and that should be the one we just ran. And we're gonna store that value as a variable called query ID. And if we wanna look at it, what does query ID look like? Hey, that looks like our query profiler things, right? And that's exactly what it is. I could inject that into a URL, and I can go look at the query. Now down here, let's create or replace this table as a select upon itself before this query was run. So we're gonna replace it in place, because right now it's all oops, select star from here, but this before is time travel. And you can either use it with timestamps or you can use it with this query ID. So that query, that's the one that was bad. We knew that one screwed everything up. What did it look like before? So if you wanna select this before you actually commit to updating, just highlight the inner part. Ooh, I don't have a limit, so that's gonna return 60 million records. That's okay, that shouldn't be a problem. We'll let that run. But we can see when it comes back, it's not gonna have oops everywhere, right here. Station, start station. No more oops, that's all gone, that's fixed. So I've done a little due diligence, that feels pretty confident to me. Let me go ahead and create or replace my existing table, so it's gonna delete it and then recreate it as the result of this query in here. And this is essentially an undo of a data operation. I didn't quite delete it, but I wanna go back in time. And not only do I wanna go back in time, I wanna affix permanently my current state to that state that it used to be. And that'll take at least as long as it took me to run before for the query. As far as caching, I don't know how results set caches resolve with time travel. Certain things, results set caches won't play with, and I suspect that might be one of them. Because you can assume that the cache data is almost certainly changed in some fashion. Okay, so what does it look like now if we run that same query? Let's see what our best stations are. Really just the top 20, we don't need to grab all of them. And we get results again. Okay, that's how you can triage some data here. It's not always about fixing mistakes. Sometimes you just wanna, say you apply a fix in production and you're gonna start using station IDs now. And you wanna double check that after the fix, that you no longer have names, you just have IDs. So you can compare how it was before to how it was today, and anything that's still equal, you wanna flag on that. And that's the kind of query that'd be really difficult to do unless you ahead of time copied the data to like an underscore old table. I'm sure we've all seen that, right? Something underscore old, old 1, old 2, old 3. That stacks up. And that's that module. Okay, so this last section is more about security. Section 8. I think we have time. Yeah, we have time. I never finish these, by the way. Even at official Snowflake events, I never get through this much content. So any questions so far? Let's knock it out. Okay, so module 8, let's use security admin. We've been in sysadmin land so far. And let's create a role. Again, this is really similar to a group. And we're going to call it junior DBA. You can imagine that our junior DBA is not someone you want to trust with all the configuration to everything or with the ability to drop everything. They probably just need some limited permissions. And let's grant that role to ourselves. You guys, I lied. You're going to have to write a little code here. So this part here, you'll have to fill in with your username. It's probably just your first and last name together. Mine has an underscore because I own this instance and I make sure everything is perfect. But if you're not sure, you can come up here and click and check. And that grants that role directly to me. Now the role has no permissions right now. It's just an empty name. But I can use that role, and really importantly, especially from an admin or a data engineering standpoint, often we've been in scenarios where we have all the permissions. So if something works for us, we hope it works for the end user because they have less permission, but we're not really sure, does this not work because they're doing something wrong, or does it not work because I didn't permission it right? Well, let's not wonder. Let's go ahead and use this role. I can set my context. And you'll notice over here, all my databases are gone because this new role doesn't have the ability to see those databases. It doesn't have the ability to use any warehouse. I couldn't, if I go up here and try to select a warehouse, there's nothing to grab. These databases are in the public scope, so that's why I can see it. Were you guys able to assign the role to yourselves and use it? Yeah, okay. So let me go back there. Now let's go back to security admin because this role needs to be the junior DBA. They probably need to be able to look at our 2 new databases. City, bike, and weather. So now let's jump back to junior DBA. And city, bike, and weather are here. And interestingly, nothing else. So this comes down to the granularity of the Snowflake granting process. I've granted the ability to see the database. I've given it no ability to see the schema. It has no ability to see the table. It needs all 3 to be able to have any sort of read access, right? Read access is usage on database, usage on schema, select on relation. Relation being either a view, materialized view, table, anything like that. And we don't go super deep into this because this can get very in-depth. If you guys are interested and you guys want some sort of private session at your company, I am a local person here in OKC. I've been here almost a year now, which is cool. And my entire job is to, for free, go help companies with this kind of stuff. So you guys can reach out to me, you can email me, or we can set something up at your company. I believe I've been on site with everyone's company here, which is really interesting. So yeah, don't be a stranger. Any questions on roles there? That's pretty simple. It's almost trivial and not useful, but hopefully what you're gathering is that the process of getting permissions to a user has a little finesse involved. And it can be more complex than just grant read access. It's a lot more complex. All right, last part. You don't have to do this. I definitely do. It's just a cleanup, right? I'm going to drop everything. This is the kind of thing that I really love Snowflake for, because if I didn't have this, I might have to send you screenshots on how to clean things up, or even worse, and this happens in the cloud a lot. It doesn't get cleaned up, just sits there. People forget what it is. Later, someone's like, what is this useful? So they delete it, but they also delete something that actually is useful. Whole process. Let's clean up after ourselves. And if you guys ever want this back, you can just run all the SQL again. And it's dropped. I am back to being cleaned in this database. I am able to run this session again in the future, and I won't have any weird errors. And that is 0 to Snowflake. Any questions? Nothing. Look at you guys, experts. Okay, well, really appreciate your time today coming out. If you need to look at this again, we'll share the recording of this. You can share that with your colleagues, and then also that PDF is really worth your time checking out, maybe on your own later. It's all the same stuff, but a little more in depth, and maybe a different perspective. So thanks a lot for coming out, guys. I appreciate it. Thank you.